Today we're going to learn how to solve systems of linear equations by graphing. The first step is to get our two equations. So let's look at our two equations. Use the graph use graphing to solve the system. Then check your solution algebraically. So I'm given two equations. Here's equation 1 and here's equation 2. The first thing we have to do is rewrite each equation into slope-intercept form. As a refresher, slope-intercept form is y equals mx plus b. So we need everything but y on this side. So let's look at our first equation. We have 5x minus y equals negative 4. In order to get y by itself, the first thing I have to do is subtract 5x from each side. So I subtract 5x from this side, and I subtract 5x from this side. I get 5x minus 5x, which is 0, so that's why I cancel that out. I'm left with negative y is equal to negative 5x minus 4. Now, in order to rewrite this, I always want the x first, which is why I put negative 5x minus 4. I take the sign of the number that's over here. Now I have a negative y. Y is still not by itself, so I'm going to divide everything by negative 1. Both sides by negative 1. This cancels out because a negative 1 divided by a negative 1 is a positive 1, which leaves me with just y over here. A negative 5 divided by a negative 1 is positive 5. And a negative 4 divided by a negative 1 is positive 4. So my equation in slope-intercept form is y equals mx plus b. Or, sorry, y equals 5x plus 4 is the equation in slope-intercept form. Now I'm going to do the same thing for the other equation. I have negative 2x plus y equals 1. Well, I want y by itself, so I have to get rid of this negative 2x. I have to do the inverse operation, which would be addition. So I add 2x. I add 2x. This cancels out, leaving me with y equals 2x plus 1. Now I'm going to graph the first equation using slope-intercept form. As a reminder, the slope is 5. The y-intercept is 4. If we're using our mx plus b, m is our slope, b is our y-intercept. The y-intercept is the point 0, 4. That's our starting point. And the slope can be represented as rise over run. So anytime I have a whole number, I actually have it over 1. So 5 would be my rise, 1 would be my run. And remember, 5 over 1 can be the same thing as negative 5 over negative 1, because negative 5 over negative 1 still simplifies to 5. Looking at over here, my m would be my 2. So I can represent that as 2 over 1, rise over run. And my b is going to be 1, so I can say my starting point would be the coordinate 0, 1. The first thing to do in order to solve this is now graph this equation. So my starting point is going to be 0, 4, and from 0, 4 I'm going to go up 5 over 1, or I can go down 5, back 1. So let's see what that graph looks like. So here is my graph. This was my starting point, 0, 4. From 0, 4 I went down 1, down 2, down 3, down 4, down 5. So I traveled this path. And I went back 1. So here's 0, 0, back 1, over here. I land up over here. I have 2 points. They're sufficient to draw my line. Once I've drawn my lines, I have to make sure I include my arrows. Now, what I do is on the same graph over here, I graph the second equation. So let's look at the second equation, y equals 2x plus 1. I graph it, okay. Here's my starting point at 1. That was my y-intercept, or my b. From there I go up 2, so up 1, up 2, that's my rise. Back and over 1, positive, that was my run. And I can draw a straight line with the ruler like this, and my arrows. Let's make sure our arrows are over here as well. Now my two lines intersect. And once they intersect, I can draw a circle around them. That intersection point is my solution. It's the ordered pair that makes both equations true. Well, what if I graphed wrong? I can always check my work. I can check my work algebraically. So I know my ordered pair is -1, -1. I can plug that ordered pair into both equations to see if it gives me a true statement. So let's check that out. I have my first original equation, 5x minus y equals -4, and I have my second equation, -2x plus y equals 1. Let's plug in the ordered pair. 5 times -1 minus -1 equals -4. Well, I know a positive times a negative is a negative, and I know 5 times -1 is -5. Now I have -5 minus -1, so that's two negatives. I can essentially distribute that in and say I have -5 plus 1 equals -4. -5 plus 1, so I'm starting at -5, I'm going one space to the right, I end up at -4. And look, -4 equals -4. Now, just because it makes the first equation true doesn't mean it's automatically true. I also have to check the second equation. So I plug in the same points, -2 times -1 plus -1 is equal to 1. -2 times -1 is 2. So I have 2 plus -1 is equal to 1. Well, I can also say 2 plus -1 is the same thing as 2 minus 1 equals 1. And 2 minus 1 is 1, and 1 equals 1. Both of them satisfied. I can say I have a true statement. And since I have a true statement, I can say solution to my linear system is -1, -1.